This is CS50AI Project 5. I'm just going to start running my code because it takes a while to get working. So in the meanwhile, I will open, what is this? I will open the directory and we can take a look at how this project works. So this directory traffic, we have the Python file and the data. So the data is composed of 43 different directories. Each directory has a bunch of pictures of one type of street sign, and so the AI through a neural network learns to classify these signs. So I had to play around for a very, very long time with the neural network to get something that had acceptable results. And I also realized that I had written my loss function incorrectly, as I state here in my README file. And so I would get maybe 95% accuracy, and then in the next run, 1% accuracy. So it took me a long time to figure out that problem. But I started with I just copied the source code from lecture and just pasted it in just to see what would happen, and I got very bad accuracy, 3%. So I just bumped up the number of filters to see if that would help. That made it worse. So then I added a second convolution and max pooling layer, and that actually increased the accuracy. So I tried that again, and that really increased the accuracy from like 5% to 82%. And then I tried lowering the filters. That didn't work. Then I tried raising them a bit, and the number of filters, and that worked. I raised it to 87% accuracy. Then I raised it again, but that really decreased the accuracy. So I undid that change. And then I tried adding a second hidden layer. That didn't work. I tried increasing the size of the hidden layer. That didn't work. I decreased the dropout, and that increased the accuracy. And then I tried to add a second hidden layer again, but that didn't work, so I deleted it. Then I tried playing around with the size of the hidden layer, and here we're getting into that issue I was talking about, where I kept getting different results for accuracy, but that was because my loss function was totally wrong. And so, I actually don't know about any of these accuracy measures, how well those represent the accuracy, because they were affected by the loss function. But finally, I tried making the filters different, so I just went 30, 60, 90, and that seemed to bump it up. And I changed the loss estimate as well, and so finally I got to about 96% accuracy, and I've been actually able to replicate this. So after many, many hours of trial and error, here we have something acceptable. And the loss function, just to be clear, I found the correct one was categorical cross entropy. I was using something else that I just got off of like Stack Exchange or something, and that didn't work. So I had to do a lot of reading to figure out the correct loss function. But yeah, and there were also different metrics. I was confused about which one to use. This was a pretty difficult project, but yeah, and here's my README file. I could not submit it through Submit 50 this week for some reason. It didn't pick up the file. So yeah, but if we look at all 10 steps here, you can see the accuracy went up from 40% in the first step all the way to 96 in the last. So the neural network seems pretty successful. Thanks for watching.